Oh, 1 minute. 1 minute. We'll start in 1 minute. Да, слушаю. Да. Ну, в ультративном моменте. Ай. Or, I don't know, no? Do we have someone online? Strange. Where are all? Where are everyone? Nothing here. Okay. Yes, well, if someone wishes to join us, it will happen. If you like to see receiver, then I will turn it. Look at face. Good naval receiver.
Yeah, you showed me in the last class.
Yeah, it's now in operational order.
Okay.
I can.
Now you
Receive all kind of
signals.
broadcasts.
So you repaired?
Yeah, I did a repair work. Most problem, someone of previous owner tried to tried to shift it into amateur range of 26, 28 megahertz. But it wasn't. Okay, I need to use what illiterate, because if you need to change range, you own in this type of receivers, you only need to adjust RF stage first and first heterodyne. I don't know why this guy attempted to reach higher frequencies, switch from 20 upper range of 23 megahertz to upper range of 28 by shifting second interim frequency. This thing do double spectrum transfer, and it has two interim frequencies on higher on lower bands it has only one interim frequency, but on high band it has two interim frequencies. 950 kilohertz and 85 kilohertz. So I tried to switch to shift up second interim frequency, but
This is antenna.
antenna cable, yes, black, and actually it's outside,
The window.
above this it's air conditioning. This small section above large auditoriums is for air conditioners, and antenna is above it. Better would be to put it above roof, but okay, it's complex.
Complication.
I don't think Dan will be happy if I ask him first. I put something above roof, and the main problem how to get signal cable from there.
It's long.
It's long. If I go, there is a cable, cable mine, cable shaft from first floor up to the roof, but it's filled with power cable. If I use it, I don't think my signal, I will get any signal except disturbance. All this power. I don't know. Maybe if I get double shielded, it will work. Okay, it's expensive and complicated.
Yeah. Can you show me? No.
So how it works? I'm not sure, but I can try. We have power. It's voice of China, Beijing or Hohhot.
When they are speaking English.
Yes, it's for a foreign service.
Okay.
I don't know. I don't speak Chinese. They should be.
Only we can receive signal from China.
Not many are broadcasting this time. But did you scan? Yeah. Forgot.
Also, I don't know.
They should be. No, it's not the best time. Usually long range. Goes better after the sun sets. And people do switch off power equipment. frequency range.
This one?
Yeah. Now it's in the range from 5 to 9. Yeah. Select one and get in. Not many chances. In this time of day, on high frequencies, you can get something. This building is full of PVM based power equipment, so
It's hard to get.
if you want to get good reception here, wait for something like 6 p.m. or later, when most stuff leaves. Chinese. Noise. Some noise. In narrow band, I cannot. Hey. But I cannot. This thing is designed with free interchangeable bandwidth. It has a bandpass filter on second entering frequency. You can choose 300 Hz, 1.5 kHz, 1500 or 6 kHz. This is 6. On narrow band, disturbances are cut off. Fit.
What is that?
I switched. See, this mode is for single sideband signals, where there is no central carrier frequency. So it's how to say reintroduced from local source. This thing controls local heterodyne free to recreate central frequency for single sideband. But if there is a single, if there is a carrier, this is AM signal. We will hear, as on Thevenin's experiment, we will hear bit signal between station carrier and local introduced. It can be used to fine tuning. This signal is fading. It's a long way from Beijing to here. I can find 17.6 something. Where they are broadcasting now. 17.6. So, my dear Chinese friends, where are you broadcasting? Why?
How is the subject? You are doing your work. You are busy. Every day you are doing this learning. It's so hard.
This one.
More than money, you need rest.
No. Where is the frequency?
Initial stage you want money, now you want rest. Okay, bro, take some rest. Take some rest. You can take 1 or 2 days. Otherwise you will be sick.
Oh, come here. Come here. Okay. Where CRI? China Radio. Oh,
Really, I was off for 4 days just for taking a rest. Today home, tomorrow is Sunday, and Monday I will be home. I always keep my schedule up.
во, CRI.
Maximum. Like I want to attend the classes maximum.
Okay. CRI at this moment can use 17570, 17490 and 17750. Which one is active? One something 176. This would be 6563. 1763, something like this. Hey. 176. 1765 they do have. Declared, they declared 1765 and 1765 is from Kashli Sabeh. What is Kashli Sabeh? Where it is? What's this? What is Kashli Sabeh? Okay, site Kashli Sabeh. How far it's from us? We can try. Kashli Sabeh. Okay, it's in prefecture of Kashgan in autonomous Kyrgyz region. Appears. Wait.
Observed is almost in the same line. There is the stressful interaction. So at the
Kyrgyz autonomous region, and how far it's from us?
And later we take all the material, we already have like
dinosaurs and ancient reptiles.
like
So
even
at
Mars
one
we
point
manipulate.
during the day,
So I think if you invest like
the
some amount of money, you can get like
costumes of
some
dinosaurs,
amount of
so kind of
certain.
to be
It's
really
better like you
qualified.
start a business better than buying an apartment. Like if you buy an apartment for 20%,
But how far it is?
50 crore apartment,
And there's also
it will take
the
long time to get
mindset
that
to try and
trophy.
involve parents in there as
That's why
well. So
there are a lot of restaurants
parents and children,
for parents for
the
it's like if
exhibitions
it is
exhibitions are designed
it is
at,
like one of the
at
famous
different
restaurant
heights. So for
there are
adults
famous
who may read
franchises.
at the Aristotle level, and then
There are
for
famous
children, they will
restaurant. As
they
a
will be
name of
taken
that,
to
people will come there
much lower
to eat.
and much
For
lower
example,
places where they
restaurant
can interact with. So that
also in that
those are the trends that I've observed so far.
So the museums are being more considerate. It is trying to
Да.
lure people in, being very welcoming
How
and
can
being
I?
selective and making a little fight pocket money by selling out the very beautiful, exquisite notebooks that I could not resist, which is thinking of the museum. So things like these are happening. The question I always ask every year on the United States, if you could recommend a museum to our listeners out there, what that museum be?
there is a famous coffee shop.
Museum in previous shows, but I'm going to mention it again. And willing to mention it every time when I'm asked which museum I'm going to recommend, which is the Chinese Archaeological Museum in Canada. A place that I would feel like going back over and over again because it's China's first state national museum dedicated entirely to
Okay,
archaeology
appears it's in
and
Kashgar
honors
region,
the
Kashgar
founding of the sanctuary.
prefecture.
And the museum itself provides
And
a
ta,
fruitful and scholarly presentation
approximately
of
distance, how can I get?
archaeological heritage as well. So it's not just any museum, a history museum that goes through
Kashgar,
dynasties. It dates back all the way to the ancient age.
city of Kashgar.
In about 8 million years through ancient Chinese dynasties and step by step to the
39,
modern
55,
era
75,
and show you
97.
a holistic story of how this land becomes what we call China today. So that's something very unique. And for history lovers who are visiting Beijing, instead of just going to, say, the Summer Palace, the Forbidden City, there's somewhere else that you can dig into and find more joy in that. That's the Chinese
Okay,
Archaeological Museum.
direct distance 4,171. They are 4,000 kilometers from us.
And there is the Chinese Traditional Culture Museum.
They have good translator. And we are, see, radio wave are not going direct. They are reflected from ionosphere, from the ionosphere. We are in the focus of the whole. They are sending wave along Earth surface. It hits ionosphere and reflects, and we are on the first hole. That's why reception is so good.
When climate changes, we will be having.
Yeah, if climate changes, solar activity. The key element is solar activity.
So how it is transmitted in night?
In lower frequencies. At night, all this high frequency area will be unavailable. So, or go up and use satellite as retransmitter, or go down for the ground wave. What's the power of transmitter? Wait one moment. Now, at this moment, CRI. Now, 1 second. this transmitter has power. One moment. Wait is so if it is one which should operate. Oh, wait 1 second. Should be 1765. They should just stop transmission. But this one was 500 kilowatts. And now they should switch to tiny one, 100 kilowatts from the same direction. Also at this moment they started from Xi'an on another 500 kilowatt. 15260 на chain. Do we see them? 15260 should appear on 15260. Five to six. Here is the carrier, but the transmitting nothing. Or they may just keep frequency. Here it is 1526. And also 17490. 17490. Maybe. Where is 17? 1749. It's carrier. There carrier is, but no modulation. Something goes wrong. I don't know. Okay, it's signal. It's signal for us. What signal? Signal that we need to talk about harmonics flow in power network. I need to do something. I need to show something. What can I show? Oh. I have my nice generator. This one I can produce my own electricity. How it works? How generator works? You have magnets to create magnetic field and rotor should rotate. Where is it? Yeah. To induce voltage in this Nice winding. And what should we see on scope? What electrotechnics theory teach us? If this is AC voltage. What electrotechnics teach us? It should be sine U max sine omega t. Yeah? Here is U max sine omega. Theoretical. Okay, this one, maybe this one isn't in good condition. Well, nice generator, isn't it? Good rotor. Spins. Okay, let's check another one. Let's check this one. Okay, this is voltage from the second one. Okay, maybe this one also damaged. More generators to look out the generator. Nice one, isn't it? So atmospheric. And base sign. Something wrong inside. Nice one. Magnets. Nice rotor. Nicely spins. But where is the sun? Where is our theory? This wonderful Western electric. This beautiful tiny generator. It's approximately 80 years old. Western electric. Something bad happens. They all produce something. You see what they are producing?
Not sine wave.
Not sine. What's going on? If one, we can say this one is damaged. But
Everyone is doing.
one, it's really fun. this beauty. What a design.
Small, still small.
Small. What a voltage. Just look at this voltage. What the hell? Where is our sign? What do I have? I don't know. Round magnetic system and rotor with winding rotates with the speed of omega. Something like this? Where is my rotor? Oh. Rod with winding. I can use simple trick. If this is off, angle. I can draw it linear. This is my off. Oh, okay, I'm switched. What I need to draw? I open magnetic system, and if I would like to draw induction as a function of alpha, where should I look? I need to take into account magnetic resistance, and here in this area magnetic resistance is smaller. Actually, I can expect something like this. And if my rotor rotates steady, if omega, what will be voltage? Induced voltage is now minus the number of turns, the first derivative of flux, yeah? Or with some factors, derivative of induction. And what will be my voltage? My voltage will be derivative of this curve, not sine. If I would like to get a sine voltage, I should have cosine in induction. Only derivative of cosine will give me some voltage. This thing gives me spikes at this area. How can I get it? I have one example here. One of the tricks, look what this generator designs did with, it has magnetic rotor and three-phase state. Look what they do. See, like barrel. I can show. Oh. Cut or barrel cuts. Some designs, they do cut poles in this way. Some designs incorporate a simple idea. They have cut-offs in this, how to say, margin areas, left empty or filled with something non-magnetic like micar. But what the, how to say, what's the conclusion of experiment we saw? If there is non-cosinusoidal distribution of induction in the generator's magnetic gap, we will see higher harmonics in output voltage. Fine. Now I would like to bring one funny generator here. One interesting generator. I have this. See? It's turn. I have here is coil inside. And 1, 2, 3, 4 somewhere. This magnets I can place as I like. Here. I would here it turns. I have a coil and here magnets. I can place them as I like. Okay, for example, N is N faces this way, so I should place this way. Here, where am I? Here are two magnets. 1 and 2. I place them. Okay. Let's see what happens. Voila. I need scope here. Yeah. This can go here. Oh, come here. Let's see, I need this small range box. And. Oh, yeah. And ground wire. Oh. Hey. Oh, here it is. Not the best voltage in the world, we can see it. Maybe if someone watched me. Oh, here is a voltage with two magnets. What if I place one more? Oh, here. Look what I done. One magnet, two magnet, and only one magnet on this side. Oh yeah, two peaks. See what happens? Too close, one at distance. Too close, one at distance. Too close, one at distance. This one maybe. Oh, four magnets. But I put magnet in opposite direction. Oh, this way is bad. 2 and 2, 2 and 2, 2 and 2. What this proves? Okay, voltage is disturbed. But what sets distance between voltage, how to say, waves? Can I say what is geometry of magnetic field? If I have two magnets like this, I will have them in opposite. If I add third one in this way, I have double peaks. So, if we speak on polyphase generator, say I have a simple three-phase A, B, C phase. My exciter rotates. What sets angle between voltages? What determines this angle? Coil placement, yeah? If I have 120 degrees here, angle between A and B will be 120. If, for example, I made this with angle, I don't know, 100 degrees, if this will be some B1, what will be angle between A and B? As we saw on magnets, it will be 100 degrees. So angle face to face in polyphase generator is set simple by geometrical placement of windings. Different placement of magnets, and we have different angle between waves. So, induction can be non-sinusoidal, so containing components 1 omega, 3 omega, 5 omega, and so on, 7. Why not with such step? Because of symmetry. Because rotor will return, after half of period, rotor will return. It's simple. Odd harmonics are in rectifier network, where they single direction. In kind of generator where rotor is symmetric, we can see only double -1, where m is integer order of harmonics. You can check it. So if we are in situation where contains 1 omega, 3 omega t, 5 omega t, and so on. Same will be with voltage. Voltage will also contain 50, 150, 250, and so on components. Fine. Now, let's look a bit deeper. And bit deeper, for example, 1 omega t, okay, here we are in 50 Hertz area. What we will see? A phase voltage will be 1 sine omega t. B phase voltage maximum 1 omega 2/3 p. And C phase voltage will be sine omega plus 2/3 p. Is it correct? Yeah, simple three-phase network. 1 means 1 omega t. A generator. But here, okay, I need 3 phase. I cannot speak to this generator because it's a single phase generator. Okay, I'll speak to this one. It's a 3-phase generator. Need excitement current to put here, and it will produce 3-phase voltage. But one tiny moment, it has delta connection. I don't have a neutral point, so I can show harmonics in all beauty. It came delta from factory. Why? Because of third harmonic. Why? Let's take a look. So at 1 omega we had something like this. A phase, B phase, and C. Yeah? With 2/3 p angle. Yeah? Correct? Now let's see what happens. 3 omega or 150 Hertz. Real generator will produce not only base frequency but also triple. It's not ideal. Okay. A as a function of time will be max 30 sine 3 omega. Fine? Fine. Phase B. Max 3 sine of 3 omega 2/3 p. Why? Because angle is designed by geometry. And what will be 3 and 3 equals to max 3 sine triple omega time. Appears what phase B equals to phase A? Let's take a look on C phase. Max 3 sine triple omega time plus 2/3. Same thing. Sine triple omega time. In my case 150 Hertz, I'll see something like this, A, B, C. Do you remember technique of symmetrical components? Or Fortescue transform? Where non-symmetrical polyphase system can be substituted with a set of symmetrical system. Direct, negative, and zero sequence.
Professor, so all phases are equal to...
Yeah, in 150 Hz, all three phases will be equal. This is strange, but okay. Let's go forward. Let's try to look what happens at 250 Hz or at 5 omega time. You have 50 Hz in your country or 60? 50? Oh, fifth harmonic. O, A.
Here is also 50 Hz, right?
Yeah? 50, yeah. Best wife in Japan. Northern Japan sits at 50, South Japan at 60. Once they divided country, northern part was how to say Siemens domain and southern part General Electric. Result, northern Japan is closer to European standard, southern Japan to the American. Okay? Who said someone goes easy way? Okay. Ace O Mach 5 and 5 omega. What about B phase? It will be O max 5 sine 5 omega time minus 2/3 p. Hey, what's the meaning of 10/3 p? First, 6/3 is the same as 2, meaning nothing. 2p, the same. So, we can subtract 6, and what remains? 4/3 p. Yeah? 1 and 1/3. What it will be? Going forward, we need to go backward. Going backward, 1, this is minus p, and we going backward. We're going backward, we're going backward, we're going backward from the A phase. So if this is A, going backward 1p, this is minus p, and one more, this is, what's this? 1 and 1/3 p, yeah? Going backward 1/3. This is, here, this part is approximately 1/3. So, what this angle will be? 2/3 p. Demon geometry, eh? How many years I spent in Demon school looking? My school teacher, it was a kind of disease. They all needed the same. This side, giant poster, cosine, sine, p by x, p by third, and this one p by 4. You had this in your school also? Yeah, it's a how I hate it. And simple poster wasn't enough. No. This tortured one of the parents to order on the factory engraved one. Engraved on I don't think, maybe even polycarbonate. But it was engraved on a glass and painted with different colors. Simple paper wasn't enough. No, it should be something. Okay, so what we get here? It's 5 sine 5 omega time plus 2/3 p. Yeah? You understood how I get there? Why? 10/3 of p equals to 2/3 p at plus. Understand?
Yeah.
Demon trigonometry. Same stuff will be on C. On here we have yellow, blue, red. In your tradition, red, blue, yellow, or red, yellow, blue. Phase marking. Red, yellow, blue.
There will be sometimes neutral for black.
Yeah,
Faces.
faces. Yeah.
Red and
Your
yellow.
black is neutral,
Yeah.
and I think A will be red,
Yeah.
and B for second one will be yellow. It's most probably.
Red, yellow, blue. Yeah.
Yeah, L, Y, B. So red, yellow, blue.
Yeah.
And we have A, yellow, green for B, and red for C, for third phase for C.
Yeah. Sometimes green is also used.
Yeah, sometimes. But in most countries, red is the first one, the A, and we have yellow, the first one here. Yeah, it's, I don't know, it's 100 years old, it's old tradition. Even first, distribution boxes and buses were painted with yellow on first phase. I don't know, maybe it's, I'm not sure, maybe it's an old Swedish standard. It should be very old, before someone even heard on Senelec. Our here local, for someone else, what are you, why, what? See all these wall connection boxes.
Yeah.
I paint them in old styles. I draw them. Some apart. How can you? Why? Shut up. It's a national tradition. I don't care. And remained. Okay, so it will be a function of time, and I shall try max 5 sine 5 omega time. Picture looks like this. A, C, B. So-called negative sequence. It's funny, but 250 Hertz magnetic field rotates in opposite direction. 7 will be normal, 9 will be zero sequence, and so on. A, B, C star, 150. A, B, C, 250. A, C, B. Rotation in opposite. 350 normal and 9 will be 450. Again, zero sequence. Again, appears like zero sequence. Okay. Sounds strange, isn't it? Can I prove it? I can in some form. One moment I will show something. Let's try simple method. I would like to try simple method. A, B, C, my table transformer. This will go to ground. I'm pointing. What I'm pointing? This nice resistance in ground wire. I will put current transformer in A. This will be my signal 1 and come here. This will be my signal 2. And as load first three lamps. I'll use this one.
It's 3 phase.
Yeah, 3 phase, 300 watts. Who are you? Who are you? This will be my second. This will be my ground. You agree? This is neutral. Okay, come here. This will be A phase. Okay, phase A connected, ground connected, phase B. And C. And for A, I can use this one. Of course, no voltage. Okay. Go, go. Go.
This is perfect sine wave.
Yellow, A current of A phase.
It's like perfect sine wave.
No, looks like normal sine.
Yeah.
Yellow is a current of A phase, and blue one is a neutral current. We can check, is it correct? I can disconnect one phase. They should be equal. Oh, this is correct. If I disconnect one phase, I should see current equal in magnitude to current of disconnected phase. So this is okay.
Okay.
Why? Why I see 0? Because our current now is 50 Hertz, and this is A phase, B phase, and phase C. If I sum them together, sum equals to 0. So, in neutral should be 0. Fine? Fine. This one is from your class of electrotechnics theory. Yeah? But here is not electrotechnics theory. For class of signal theory, I will take modern LED bulbs.
You did the hairstyle.
Yeah.
Everyone.
Yeah, but like we will see.
So do you want what?
Yeah.
You watching you will watch like only like soft.
Yeah.
What is credit?
No, it's no good to just become rough. It should be rough. Yeah, rough.
How you do it?
It's like a phone.
Friend.
Yeah.
He's making
She,
anything.
What's up?
She's making anything.
Ah, okay.
like, she is black.
Oh, here we are.
Paid no?
So I'm in
How much?
25. Then I go to the Sunday, to the barber. And the barber collects 30. So
What the noise?
She connected but like the end.
Good.
Until
Yeah.
side and everything.
So together is 55. Okay. Depends on the star. If I pay the full star, then it might cost 35 or 40. Then plus barber to be like 90.
You don't know how to do it? No? No.
Yeah.
Yourself.
What would you say about this?
This is crazy.
Yellow line is a current. Because they had a red driver this ball. Schematic starts with DC stage. They have rectifiers on input and then PWM driver. So it's a current of rectifier. We see current when DC stage capacitor charges. We see current in form of pulse. This nice yellow line is a current of this.
Professor, it is because it's diode.
Wait 1 second. Wait, which one is A? Yeah, it's because of rectifier. Oh, it was current of this one. It's because of rectifier at the input. What do we see in spectrum? I'm interested now in this red line. Oops. Get lost. Hey. Okay, here is my reading. This line number 1. 50 Hertz, 150, should be 250, yeah, it's 250, and so on. So what we see? First, third, fifth, 7th, 9th, and so on. Going down harmonic road, double M minus 1. This, now red line is a spectrum of A phase current. I can wait second. I will try to store it. Okay, here it is. Can you please stand? Yeah. Can you see? I stored in white line spectrum of A phase current. Now I will switch my spectrum analyzer to the channel B, and channel B is a current of neutral wire. And what we see? Nothing at 50 Hertz, nice peak. I can make a big shift. Oh, see this peak at 150. Nothing at 5th, nothing at 7th, and again. Oh, who's here? At 4, yeah, at 450. You see? 3rd, 9th, and so on. Sum of currents of first harmonic is 0. Sum of currents of 5th harmonic is 0. Sum of currents in 7th harmonic is 0. But sum of currents in 3rd harmonic will be triple. Sum of current in 9th harmonic will be triple. Magnitude, they are in different scale. Be careful. Yellow line is in 20 millivolts per unit and blue line in 50 millivolts per unit. They are in different scale, and that's because these are in different. They are not in equal scale. But here it is. Do this picture we see, how to say, approve my theory, what 3rd harmonics vectors are unified. Yes. You see a nice picture. When phase current contain all the set to M minus 1, And ground current or neutral current contains only 3 amp, where m is integer. Only third, 9th, I don't know, 15th, and so on. Not simple triple M. It will be 2m minus 1 multiplied by 3. What it will be correct? Yeah, I hate this a lot. Can go back. I need second board. Oh, this is old picture from electrotechnics theory. Old days were better. Okay, so conclusion for today. If load is nonlinear, current will contain higher spectrum components, and key in three-phase network 50 Hz acts as a direct sequence, 150 Hz stands on place like a zero sequence, 250 rotates back. Magnetic field has an opposite phase sequence, and so on. Next time, what will be next? Next time we will speak on transformers. What happened? What a reality when we concern real transformer with iron core, not the theoretical one from the electrotechnics theory. Real. Next time I will try to find